Okay. Thank you. Good morning, all of you. And let us start the second part of my lecture. The topic was recent advances in solar cells and modules. And last time we had, I'm not able to, yeah. Last time we had discussed about the first part. The first part was advances in solar cells. And what last time we had seen was that these many types of cells are there: crystalline, thin film, and emerging technologies. There are so many types of solar cells are available, and we had discussed everything. And then we had detailed discussion on that. And finally, now we had seen that especially that I'll come to that. Yeah, spinach. So finally, we had the conclusion that this was the take home ideas were there at that time, the last time. And so this was the take home ideas for solar cells. Now next, what we are now talking today is part 2, advances in solar modules. As I told you, cells make modules. So many cells in series are modules. So there are two types of modules mainly available. The first one is crystalline type, normal crystalline type. Crystalline has polycrystalline and monocrystalline. So this is 6 by 6 inches of the solar cells, and they are connected in series one by one. So there, one example I'm giving you is 72 cells, 6 by 6 inches, 12 into 6, and that is having 172 watt peak. That is the wattage of the module. This is a sample. Similarly, if you take thin film, then in the thin film, it is a different type. It's like strips. So only 4 mm thick width and 1.2 meter length. This is the one cell. This is interesting thing in that thin film. So only 4 mm width and 1.2 meter is the length. So you can see these are the small cells here. And here we had 72 in the crystalline, we had 72 cells here. Here we have these strips of 150 cells. And that is sample of cadmium telluride for solar cell. And so you can see here that this is a module, wattage is 78.6 watt. So this is the basic difference of the crystalline and this one. Now we are coming to the main thing, advances in solar modules. So these are the normal one I have shown you, which is normally available. Now, what are the advances? These are the different types of different types of modules available in the market. And I'm going to talk about one by one each for that. First one is glass module. So what is a normal module? If you take this normal module, the front one is glass. Below that, it is solar cells. And back side is a plastic sheet, that is a white sheet. So back where this sheet is there. And this is the typical normal solar cell available in the market. But what is a glass modules? Glass front one is 4 mm and back side 2 mm. So you can see you might be remembering that last time I told you how cells are made. The front one is grit, metal grit, and the back side it is just the silver paint. So that's why it looks like this. Now in this one you cannot see the back side because it's a plastic sheet. But in this case, glass module, you can see front also this kind and back side the metal coating also you can see. That is the advantage. That glass cover, it has the weatherproof, frameless, stronger and fire resistant. This is the advantage of the glass modules. Next one is bifacial modules. See, here it is one top is a grid, metal grid. But if you back side is just the metal paint kind of thing, this side. But if what there people have come out that you have the metal grid at the front also and metal grid in the back side also. Then back side also can also generate some electricity. So bifacial modules are basically glass modules. Both sides are actually they have the metal grids, and they allow sunlight through rear side also. So basically it has an efficiency gain of 11% and maximum efficiency is 21%. And additional energy harvesting is 25%. So it is weatherproof, frameless, stronger and fire resistant. So how it looks, bifacial modules. You have seen here, this is front is looking like a solar cell grid, and back side is just a paint. But in this one, you just see both sides are similar. So back to back and both bifacial modules. And then you can see through it. Here you can see sunlight is coming through it. Flexible modules are very interesting thing that I would like somebody to start manufacturing in India. This is very simple. Monocrystalline modules are there, and it has a flex. It is a size is 2 meter by 0.7 meter, and flexible, lightweight, and thin. That is advantage. It can be fixed at the curved surface also. That is advantage. Tilted surface, facade, and it has no glass. So problem of breaking is not there. Less surface energy, hence the less dust collection on this one. So you see how it is fixed on the surface of even the curved areas can be covered with solar cells. Installation is very easy. Just stick with the glue. You put the solar panels and stick with the glue. Modules with IMM. IMM is individual module monitoring. Normally what happens that you have the monitoring system where the centralized monitoring is there through the inverter. But this is an interesting module which is having its monitoring system also inside the module itself. So what is happening? It gives a real-time data of module level. So plant efficiency is improved 3% and O&M cost is savings 50%. So what are the items in this? IMM sensors, string reader, gateway, and the web portal. So IMM sensor in each is like a small chip in the module. And what it transmits the data to string inverter. And in a string reader, it gives a string level data, and then gateway is collecting all the data to the gateway, and gateway finally gives your web portal. Web portal, what it does, it analyzes, edits the data, detects individual module performance. So its alerts also it provides SMS, email, etc. Any problem, then it is given by that. So internal module monitoring is very interesting thing. Now BIPV modules. BIPV, normal modules are called building applied photovoltaic. Building applied photovoltaic means what? On the building you just put it. That is building applied. But if you integrate the module in the roof itself is made of solar modules, then it is called a BIPV. Building integrated PV, photovoltaic module. So what is the advantage? Saving in material, electricity cost is reduced, and architecturally looks nice. Modules are thin film, crystalline, transparent, different types. Solar skin is also very interesting thing. Means if you have the roof of that color, the solar modules are also of that color. So you see here, these are not tiles. The roof tiles, these are not roof tiles. These are solar cells. Interesting thing. And this is transparent one for the light to come inside. And this is facade. Half-cut modules. Half-cut modules in general solar cells are 16 centimeter by 16 centimeter. But if you half cut, it is 16 by 8. So 60 cells module if you have, then 120 half cut modules will be there instead of 60. What is happening? The resistance is reduced. And due to that, you get efficiency gain of maximum 1% and power gain 3 to 5%. So it has actually 3 bypass diodes and 3 junction boxes. So larger spacing between individual cells are there. So that is a better, you get better efficiency. So you can see half cut modules. Normal cell was like that. Now it is half cut. Half part is this, half part is this. So there are two connections here. And so 60 cells has 30 watt, 30 volt, 30 volt. They are together. And this is size, you can see the size, half module. So 6 cells strings are there, 3 diodes and 3 junction boxes. Shingle cells modules. Shingle cell modules are basically very simple thing that normally you might have seen last time I had told you that one top of the one cell is connected to the bottom of the other cell. And that is through strips. That is through the small strips. Now, in this case, there is no strip. One cell is just attached to other one, and there is a conductive adhesive yellow color. You can see here, it's adhesive, conducting adhesive. So one over other, just like tiles. Then ribbons are fed underneath. So that's why advantage is that here that you get eliminates 2 mm gap. So you can have the larger area you get. Same area you get more power. Lower ohmic losses because there is no strips in between. It's just one cell over other. Electrically conductive adhesive is fixed. So it's very simple. And the increased energy generation due to lower cell operating temperature, this is 10% gain. Why lower cell operating temperature? Because the strips are not there. There is no connection like that. There is direct connection. So improved aesthetics, looks also nice. Now this is very popular, PERC modules. Nowadays you will find in the market, lots of modules are PERC modules. So it's a passivated emitter rear contact. What is happening in normal modules? Normal modules you will find the light falls at the top, it is absorbed, converted into electricity. Remaining light just passes through. So that means 80% of light passes through, only 20% is received and converted into electricity. But in the PERC module, what happens? There is one reflecting matter here, dielectric passivated layer is given here. And due to this reflecting passive layer, passivation layer, what happens that at that time, the light that has passed through the rear without generating electrons, it reflects back into the PV cell by dielectric layer. Means light which was passing through, it goes back. Again, it is absorbed. So that means photons which are absorbed get second chance to get absorbed. This is the advantage in PERC module, getting second chance. So that means you get better efficiency. So even in weak light, it works. And reduces electron recombination that are producing additional electric current. Possible to achieve up to about 1% efficiency gain. And this is becoming very popular. PERC modules are very popular. They are available in the market. HIT modules. This is one of the best because in the market. And what is happening in the HIT module? Intrinsic means silicon. The amorphous silicon is put in between this one, N-type silicon. And advantage here, this is good research. The advantage here is that you get better efficiency. So intrinsic silicon, if you know, I think people who don't know, for them I will tell you, if it is P-type, N-type doped, they are called doped electrons, the doped semiconductors. And if there is no P type, N type, it is intrinsic. No doping, that is intrinsic. So amorphous silicon intrinsic layer is put in here, and that makes it very effective. And you will find that it lower temperature coefficient is there, and it has a high efficiency, 19.7% efficiency constantly. That is a beauty. So another thing is about modules with battery. Modules with battery means thin rectangular battery, that is lithium iron phosphate, which is 20 by inch by 10 inch, and weight is 7 kg, which is attached in the module itself. Normally what happens, that you have a solar module, then you go to, then you, that electron, this electricity is taken from the module, and then you uh, pass through charge controller and give it to battery. And so module is separate, battery is separate. In this case, what is happening, such modules are there, where you will find that even the cell, the battery module itself is having a small battery, 20 inch by 10 inch attached to the back side. So a 60 cell module with 300 watt power, it has 650 watt hour in this battery attached to that. So it can be used at the utility scale also. The best part is that it is modular, better than central storage, shuts down over 50 degrees centigrade. That is the advantage. That automatically, if the temperature increases, it shuts down. So it's a recent improvements have been done. What? Passive thermal regulation technology is there, and shields the battery from both hot and sub-freezing temperature. Sometimes you will find that even at freezing temperature, when the snowfall is there, the battery stops working. But that it has shield for that also. So as a result, the long and bankable service life is obtained. Next is module with optimizer. This is development, and it's a very nice development. That if you have the optimizer fixed, it's like giving more output than normal modules. What is happening in normal modules? 7 to 8 morning, the power is generated, but it is not picked up by the inverters, because inverter needs minimum voltage, and 7 to 8 in the morning, minimum voltage is not achieved. So optimizer, what if you attach to the module, what does the optimizer does? That it actually converts that low voltage power into high voltage power, and then ultimately this it is optimized to the maximizing the energy at that time. And that's why even 7 to 8 morning light, and the evening 4 to 5, 5 to 6, that is normally wasted. But if you have optimizer, you can use all these things. Another advantage with optimizer is that it is shuts down the modules when the DC voltage, when the inverter or grid power is shut down automatically. That is the beauty with this. The first thing, it monitors. An interesting thing is, see, IMM, I have shown you that the internal and the module monitoring was there inside the module itself. Now here in the optimizer, you have two things. One is optimizer, and second thing is monitor. So internal monitoring is also being done, and it is like optimizing the power also. So more power with optimizer, with module monitoring. So flexible installation design is possible here. Multiple orientation. In normal cases, if you have different orientations, you don't get power property. In this case, you can keep it a multiple orientations. One can be south, one can be north, one can be east, and even then you get good power. So different tilts, different orientations. So module types also you can use different. Normally, what happens that you need to have, if you have 350 watt module, then all should be 350 watt module. It's a necessary. Otherwise, your power will be reduced. Last time I had told you that how power is reduced with one just modules getting shaded. But in this case, the beauty is that even if one is shaded, the others are providing because each one has optimizers. Each module is itself an independent system. So you have advantage of multiple orientation, multiple tilts, and module types also multiple you can use. One can be 300, one can be 350, and you can have different companies also. So that is the beauty with the module. Module mismatch is okay for it. Normally module mismatch is not accepted. But here module mismatch is accepted. You can see here, this is a very small thing, optimizer. And you just attach it in the back side of the module. And just attach it and then in the side, and then it gives you everything, optimization and everything. You see, this is the picture taken of on the screen of the computer. Each module wattage is given here. So it gives the monitoring of each module health. One of module is working nicely, other is not working. Everything you can find out from this. So that is the module with optimizer. And it is now becoming popular, very popular. The only thing is that little cost is added. So that is the reason why it is not. Otherwise, this is the best thing to use. Now, modules with inverter. Modules with inverter is so interesting thing. Micro inverter. So normally, what you do, you have this one module, then you attach to many modules in series and parallel, and then collect that power and then give it to the central inverter. So inverters are collecting the power from different modules and then converting to DC to AC. Here within micro inverter, the beauty is that at the module level itself, you are getting that DC to AC. And that is the one of the best thing. Why we say it is a very good thing? Because there is no modular system. So single point failure is not there. Suppose if all the centralized inverter is there, one inverter is gone, the whole modules are not producing power. In this case, each module is producing power. So no problem. If one module is not working, other is producing power. And in the string voltage, generally string voltage means, I think most of you know that many modules in series are called string. So string voltage in the DC voltage, it is added. 600 to 800 DC voltage is added generally. But if you have inverter, you have 600, 800 volt AC. Now everybody knows that 800 volt DC, if somebody touches, he will die immediately. But 600 and 800 volt AC, if somebody touches, there will be shock, but then ultimately he will not die. So DC is such a bad thing, but this micro inverter is avoiding everything. It is producing power at the DC to AC at the module level, and at the same time, the collected power is having the voltage AC, so which is safe. So, and another beauty with this is that no string sizing is required. In the DC voltage, if you keep in the string, then 800 volt limit is there. You cannot have more than 1000 volt if you keep DC, it's not allowed. I mean, as per the norm, it is not allowed. But if you keep the AC, no problem. You keep 1000 volt, you can to 2000 volt, no problem. So that is the string sizing is not required. You don't restrict that only 20 modules can be attached, only 30 modules can be attached. Here you can have any number of modules. If you have the inverter, micro inverter with this, you can have any number of modules attached to it. So all AC design is there, no complication. We are very familiar with the AC design. So no complication, all AC design. Now, wearable solar modules. Wearable solar modules means it's like a cloth. So, cloth having solar cells. So, you have the curtain that is producing power. Tiny solar panels are stitched into the fabric of the clothing, and application is window curtain, heating, car seats. So recently what they have done, there is single solar cell textile has combined high energy. So that means you get the high energy and efficiency, stretchability. You can stretch the solar cell and stability in air and water. Recently they have got it. And ultra thin organic photovoltaic layer converts sunlight into electricity at a efficiency of nearly 8%. So that means you can see here the wearable solar modules, they are basically uh, low efficiency modules and still under development. You cannot say that it is really highly developed, but people are trying, and therefore they have found up till now high energy efficiency, stretchability, and stability in the air and water. They have still achieved, but still it is being developed. You see how it is looking. These are the solar cells in the curtain, and uh, these are connected wire connection in between. That means curtain can also produce power. The solar agro power harvesting. So this is at present happening at many places. At the top, you have solar power production, and below that, you have the agriculture. So inter-row spacing is there. In that inter-row spacing, you can have you can grow lettuce, spinach, beets, carrots, chard, radishes, and other things. Not all crops can be grown because shadow is there. So that's why only those crops can grow which can grow in shadow. So the difference is that normal modules are at this level, at lower level. But here you have to increase the height of the modules. Increase the height of modules, and you can have the power generation at the top and agriculture below that. This is happening. You can see tomato here being grown, and at the top we have the solar modules here. Now, same thing can be done with the solar agro power harvesting. If you have the roof of the greenhouse, this can be done very easily. The greenhouse, if the roof of the greenhouse is having solar modules, and below that you have Pune has so many greenhouse farming going on. They can have this, and this is now, so solar panels are now less costly, so it can be used. So they are what they are in the greenhouse. They are growing exotic and non-exotic, the vegetables and fruits. Now I am repeating this. Last time I had shown you Government of India promotional schemes. Many people have joined today new, so that they will know the great opportunities for industries. There is MSIPS. If you go search this MSIPS on the website, you will find the whole policies given there. And you will find 20 to 25% subsidy is being provided by government capital expenditure. 20 to 25% subsidy is being provided. This is a huge amount. Suppose one 600 megawatt plant, if it is installed, you generally have to spend around 600 crores of rupees. Now 25% of 600 crores of rupees is how much? That much you get subsidy. If you go for manufacturing of the solar cells and solar modules, these are the solar cells and ingots. So Here you will find that reimbursement of the countervailing duty is also the import tax is you can reimburse. Excise duty can be reimbursed. And other schemes are domestic content requirement. Means government is promoting that there should be domestic manufacturing. So that's why out of the total targets of the government, certain targets have been kept reserved for the local manufacturers. And local manufacturers up to what target? 1200 megawatt. It is government is proposing. And Kusum scheme is like Kisan Unnati this Yojana is there in that Urja Suraksha. So Kisan, this Kusum scheme is for the farmers. They can produce power. They can have the solar pumps. So that is also for them, and it's a very good. This year, lots of funds have been allocated to the Kusum Yojana. And the new rooftop schemes are there. All the new schemes which is mandated is it has to be run through this year, the domestic solar cells. So that means local manufacturing is being promoted. And tenders are announced where they say, the government is saying that PPA, we need to sign with you. So you quote the tariff bidding. You bid the tariff in such a way that we will make it sure that all the modules are used in that manufacturing, and we will take all the powers if you manufacture and produce power, both. So it is like manufacturing capacities, setting up manufacturing and producing power, then the government is ready to purchase that. This is bidding is already done, and some bidding are already going on in the process. So in the budget, you will find this year budget, Finance Minister has announced the production linked incentive. Means as you produce, you get the incentive. That is 4,500 crores. In this year, it has been announced. Incentivize the solar manufacturers. So local solar manufacturing is being promoted to encourage domestic production duty. Now, what is the way out? That if you want to have the produce a local production to encourage local production, one way out is that give the subsidy or give the promote them by giving incentives. Second way out is that discourage import. So discouraging import means what? You just add that, increase the 5 to 20% duty. Custom duties have increased 5%, 20% on inverters. And solar lanterns 5% to 15%. Increasing the custom duty, automatically this will reduce the import, and then it will actually this will reduce import. Also, it can make the local manufacturing cheaper compared to the foreign import. That is the strategy. So an exemption to all items of machinery, instrument and appliances, components and auxiliary equipments of setting of the solar power generation projects, these are also given by the government. This is announced. And most important thing that I will like to draw the attention of all of you is the basic custom duty, BCD. BCD, if you search on the website, you will find government is I think within a month, they are going to announce that basic custom duty they are going to be proposed on all the solar items that is imported, 40% on modules and 25% on cells. So this is purpose is to avoid importing or make the local manufacturing. This one. So now take home ideas. Take home ideas. I really again thank Mr. Chaitanya, who told me that you, doctor, you do one thing, you do everything, but you make a slide which is having take home ideas. I like this idea. And once again, thank you, Mr. Chaitanya, Anil Chaitanya. And that's why I have made I had shown you last time take home ideas for the solar cells. Now it is take home ideas for glass, this one for modules. The glass silicon solar modules can be manufactured. It's local skill. See, we have so many glass factories in the country. and they are experts here. Why can't they make the solar module, glass modules? It's very simple. Then similar way, HIT modules can be done, but it is actually it is right protected. So only Panasonic has a right. So that's why you have to collaboration with the Panasonic. India, it can be manufactured. HIT modules, I feel it is the best module at present level which can be run. Now, why it is not being popular? Simple thing. It is being imported. And in the same thing, if it is produced, you have the collaboration with Panasonic and start producing in India, HIT will run like anything. Similar case is a bifacial solar modules. We have the technology to single phase printing. Model technology is already there in our country. So many factories we have in country who are doing this single phase printing of the solar cells. Now, the technology is similar, so why can't they do the bifacial also? Both sides they can print. The manufacturer GIS module. This is the best thing I love. I love it. GIS, CIGS. This must be taken. Somebody must take lead in this CIGS. And collaborations can be done with the Solar Frontier Japan, Ascent Solar Tech US, Siva Solar US, Enterbrite Taiwan. Enterbrite is being already imported in the country. But these countries, Taiwan, one can have collaboration on the CIGS modules. I had to explain already why CIGS is good in the last lecture. CIGS is a very nice thing to happen. There are so many qualities. I will not repeat here again. Then flexible modules, it's a requirement at many places where you need to have the curved surface, you need to have solar module. So there are Sunman in Australia, High Flex Solar in US, you can have collaboration with them. Production of shingle solar cell, it's a very simple, I told you, conductive adhesive, you have to one by one, you can put it, you can manufacture, there's no problem. Then solar power with agriculture, it's a highly profitable business. You can have solar pump there for the water pumping, and then at the top you produce power, below that you have the agriculture. What else you need? But this is still not popular, I don't know why. Many people can start solar power with agriculture. And then I'm giving you a report, some report has come that the global BIPV market will reach USD 7 billion by 2024 and growing at the CAGR of 15% during 19 to 24. So India has a great potential for this one need. It needs to be exploited. And I think the BIPV has a great potential in country. Let somebody take lead in this one. Okay. All the best. Thank you. I think I have completed in 40 minutes.
Yes, thank you very much. That's exactly 40 minutes you have completed. And we all appreciate your 2 sessions. I'm sure the TTA members, present and future, are immensely benefited by your presentation today. And definitely it is going to help when they will be planning for solar energy on their rooftops. And it's a really interesting presentation. We would like to go ahead for the question and answer sessions. So request participants to identify your name and then ask the questions.
Sir, my name is Adish Telang. I am a son of Mr. Ramesh Telang, who is a member of TTA. I am not the member as of now. I had read an article recently about the Western countries converting their roads to solar powered cells. That is, the road surface itself will, I mean, in our, we will have dust and other issues. But is the government or is any company work, because roads within the companies or our national highways also, they are a big surface area. So is anyone working on this within the country?
Within the country, people are still importing. You are talking about this BIPV modules, no?
Yeah, see, if we Google solar powered roads, you will see a lot of experimentation going on that they are making trafficable roads. Actually, vehicles can drive on them.
Yeah, I just see. Thing is, it is available. China has done, and some not in India.
Okay.
Thing is that in India we hardly spend on the R&D. So R&D is like the risky thing. So that's why in India R&D is less, and that's why In India, I don't think anybody has gone for it. But in foreign countries, solar roads have been made with the transparent roads.
Yes.
And below that, solar cells are there. They are running, but they are still experimental, not yet commercialized.
Okay. Okay. Thanks.
Okay, thank you. Yeah, any
Hello?
more? Next question. This is very interesting. We have also seen a lot of photographs and reports on roads generating electricity. But in Gujarat, they have done it on canals. So they are not. It's not impossible to be on the road. I think Dr. Sudhir can comment.
I couldn't get it. Please, your voice was breaking. So please repeat the question.
No, the question was whether Indian roads they can generate electricity like what they are experimenting in China and other places.
Only sophisticated areas, not general road.
Okay. Next question. Any more questions?
Yes,
Yeah,
I have a
yes,
question,
sir.
Dr. Saab.
Yes.
Yeah.
My name is Bedarkar.
Yes, please.
I mean, I missed your last lecture. I'm sorry, but this was very, very good, very interesting. Are there any solar cells with diffraction grating in front? Because I believe diffraction grating can provide you with a larger amount of energy because it gets concentrated. Is there something that you could sort of guide me on this one?
Concentrating solar power, you are saying, photovoltaic.
No, a diffraction grating before the solar cell.
Yeah.
I have a reference that says that it gives you higher efficiency and more power. So is that true? And if so, does anybody do it?
No, I couldn't get differential grading, you are saying.
Diffraction
Grating.
A diffraction grating, an optical diffraction grating.
Oh, deflection.
Before the above
Diffraction.
the solar cell, at a small distance above the actual cell, can provide a higher power output. Do we have any
Energy collection will be high.
Sir?
Yes. Somebody else was talking. Talking about all these things are in laboratory at present. And laboratory they find.
Yes, sir, I didn't get you.
All these things are in laboratory. They're laboratory research.
Okay, sir.
All the commercial things I have explained just now, but
Okay.
it is true what you are saying that you can in the laboratory you can achieve that, but by bringing it from lab to market,
Yeah.
still they are not there.
Okay. So
Okay.
there are studies of this type that the diffraction grating brings extra power.
Of course. Yes.
Okay, sir. Thank you.
Yeah. Any more questions, please?
Yeah, sir.
Yes, sir.
Myself, Sandeep. I'm member of TTA and I'm already in solar business, having portfolio of 1.6 megawatt of commission plant rooftop. Yeah, Doctor Sir, I have one question. You mentioned that a 600 megawatt module making plant can be possible with government intensity. So my question is, what is the best or lowest feasible plant capacity which we can install, which can be viable?
Commercially.
Yes, sir.
Commercially, not less than 300 megawatt annual.
No, sir. Why I'm asking is because it's a huge investment. Then that's what.
It is, yeah. Lower. See, the lower capacity you cannot afford commercial.
Okay, sir.
That is the thing. So minimum 300. People have tried for 100 to 100 megawatt per year, but they could not. The affordability is not there.
Okay, sir. Okay. And sir, my second question is regarding flexible solar panels, which you told. Sir,
Right.
any idea you have what's the investment required for manufacturing of this?
Sorry, I don't have the data for that.
Okay, sir. Okay.
You can talk to them. You see, I have given the name of the company already. I have given to you. So you just talk to them on everything is available.
Yes, sir. Okay, sir. Thank you, sir. Thank
Hello.
you.
Yeah. Please go ahead. Next question.
Sir, this is Narendra from Hyderabad. We are into solar EPC business. Thank you, Dr. Sir. I mean, I've attended this last session and this session, and in this session, we have some requirements, sir. I mean, regarding the flexible modules. One of our client is into landfill business. They are, I mean, it's a useless. I mean, once it is landfill, it's a useless land. We want to set up a solar plant there. We are looking for solar flexible modules. I mean, what will be the efficiency of that, and is it be viable if we go for the flexible module?
Yeah,
Or
actually, yeah, sorry, please complete your.
yes, I mean, or we need to go for this conventional modules only for the landfill? I mean, landfill is it's basically it's not a flatted surface. It's somehow it's a curved surface like a globe, half a globe like thing will be there. For
Right.
that, I mean, what you may please suggest? I mean, the best
See,
option.
Flexible module is a very interesting thing. When I studied, I thought, oh my God, how they have made a flexible module. Because see, my basic research when I did, I found that flexible module making is a tough thing, and it will break, and stability will be difficult. Then I went deeper into that, and I found it is nothing. It's the same for solar monocrystalline modules. They are put. It's like a redesign, re-engineering. So the same efficient solar monocrystalline modules, they are put under the flexible cover, and that is the beauty, the efficiency, no problem. And then the only thing you will have to take care that it should not fold too much that it should break. Just flexibility has to be used, and that is the advantage. So flexible modules are efficient and technically viable.
Okay. So, I found that I mean, somewhere in abroad, I didn't remember the country name. Somewhere in abroad, they set up the flexible solar plant on the landfill itself.
Yeah.
But I mean, I'm looking for the manufacturers. Thanks, sir. I mean, you mentioned few names for the suppliers.
Yeah, you contact them. Yeah.
Yes. Thank you. And one more thing, sir. I wanted to know one of my technical note. I mean, what will be the maximum mismatch in the wattage or mismatch in the voltage while paralleling two different modules or two different strings?
See, straight away you cannot say, but the thing is that I told you last time also. Suppose you have 300-watt module in the series, and one of them is 280 watt.
Okay.
Then that whole series will give you 280 watt only. Whole cell will become to 280 watt. All cells. So that means you maximum possible you have to make it sure that all of them should be 300 watt. And at the most, you can have the plus minus 0.5%, not more than that.
Plus minus 5%.
0.5%.
0.5%.
Yeah.
I mean, in respect of voltage.
0.5% variability.
Okay. Voltage also, sir? For voltage
Not
also.
wattage.
Okay. What about voltage, sir? I mean,
voltage
what
will be
can
same.
be?
See, voltage will be almost same.
No, sir. Can I parallel some different voltage modules or different voltage strings?
Different voltage strings. Yeah.
Yes, sir.
Yeah,
If that is the case, what will be the tolerable voltage?
Yeah, then you need to have that optimizer and or inverter, micro inverter.
Without that, I mean, what can be the allowable range?
I don't think it's advisable.
Yes, sir.
I don't think it's advisable.
Okay, sir. Fine, sir. Thank you.
Yeah.
Okay. Any more questions? I think we must thank Dr. Sudhir Kumar for this wonderful presentation, which has provoked many participants thinking on various aspects he has discussed. Once again,
Not audible.
I would like to announce that.
Hello, Mr. Ravde, you are not audible. Some problem? I think everybody is listening here.
We must thank Mr. Ramesh Telang for supporting TTA by donating this Zoom platform.
No, I'm not able to listen. Hello.
I think Mr. Rabde has some problem.
Yeah, he had some
So
problem.
I will do my summing up.
Yeah,
And in the meantime, if he is able to audible, he can come back.
yeah.
At the outset, I must thank Dr. Kumar for two very interesting sessions full of lot of knowledge and experience of his maybe 40 or 45 years of dedication to this sector. And as his name suggests, Sudhir means good, Sudhir means wise. So he has given good and wise advice. And I'm sure last time we missed the question and answer. So this time particularly I asked him to allow time for question and answer, and we had very good questions and answers. And one of the question came of viability of smaller plants, you know. Now I have been thinking of COVID-19, and it has brought about a paradigm shift in the way the business is carried out. People have gone from from global to local, from urban to villages or smaller towns, from office to home, and from formal to informal way of doing business. And although the situation may improve, these trends are likely to continue, particularly in the light of Industry 5.0. I had written an article last year on this subject that is going back to the Gandhiji, that is going back to villages. And that is already people are talking of 5.0 abroad. We are still at 4.0. We missed the 4.1, we missed the 4.2 electricity even today. Our electric consumption per capita is 0.1 kW, as against 10 kW in developed countries. And some time back I had read that 0.1 kW is equal to 1 man. So we are ourselves, and we get 1 man through electricity. Abroad, they get 100 men to improve their production and productivity. Now it will be a long time to get us to electricity generation of that quantity, and particularly Rabde recently raised a very valid point about electric vehicles, that they are based on electricity generated mainly through coal. A very interesting graph he had reproduced, you know. And he then raised the question whether the EV is the right thing for us. The EV will be right thing for us provided we go for the green energy. And green energy means converting the solar energy to hydrogen directly. There are 5 or 6 different consortiums working on this. And what they intend to do is to produce hydrogen through the solar PV cells, you know. There is a very big consortium going on in Spain. And there are many other initiatives in this regard. So once that takes place and hydrogen will be the fuel of the future, then his questions will be answered. But in the meantime, to address the situation that has arisen out of COVID, I think there are some developments which are taking place. For example, floating plants. We have many reservoirs. We have many we have a whole coastline, and we have ponds, and we have big lakes, you know. And floating thing could be, the idea is to produce electricity locally and use it locally. That is 5.0. And in that case, the economics of a large scale plant does not arise as far as the PV is concerned. So with having a floating PV cell, which has many advantages because the cooling takes place through the water and support is not required, many advantages are there. Another area where people are working on buildings, instead of having the traditional roofing and traditional windows, the PV cells will form all those, you know. And we have seen another lecture, we have seen that garage roof, where you park the car, you can have a PV cell on the top, and charging can take place while your car is waiting there for 8 hours or 10 hours, you know. So many important things are happening in this area. And we in India, as doctor has correctly brought out, we do very little in terms of research and development. All that we have been doing even now is reverse engineering of the excellent development that have taken place abroad. And out of that also many parts we import, many critical parts we import, you know. Now it is the objective of Technology Association to change this particular Indian mindset. Not that Indians are inferior to anyone else. In the NASA, they say that if the Indians are withdrawn, the NASA will collapse. The Mangalyaan of USA, which was sent, was headed by Indian lady, you know. The DARPA, which is the defense setup in United States, which brought out from internet to many more interesting global phenomena, was also headed by an Indian for many, many years, you know. So by large, Indians are extremely good when they go abroad because the system exists. In India, the problem is that we do not have the systems, and more importantly, we do not have the vision. It is the objective of the Technology Transfer Association to change that. That is how we have started this concept of think tank, that is thinking ahead, way ahead, you know. And I hope that with cooperation of excellent executive committee that we have and the support we are getting to our lectures and more people are joining as our members, we will be able to change the Indian mindset and over a period of time, not just celebrate 20th of February as Raman effect, which is 93 years back, but there will be many more effects which will be there, and we will be celebrating those by getting Nobel Prizes and having breakthrough discoveries. So Dr. Kumar has given us food for thought on all these areas, and we are grateful to him. I think Rabde is back in circulation, so I'll leave it to Rabde.
Okay, thank you, Harpre, for this wonderful sum up. Friends, yes, solar energy is the talk of the day. And next Sunday, again, we will be talking about solar energy. Mr. Avinash Abhyankar from Appropriate Technology has done a lot of research on BRT, and is confident that our BRT bus rapid transit, which is people say failed in Pune, can be Atmanirbhar. BRT can run on solar power. He has done an extensive study and research, which he has published in the Marathi article last Sunday, Sakal. So we will be listening to and understanding his idea how the BRT can become Atmanirbhar, self-sufficient as far as electricity requirements are concerned. And if that happens, and if it is proved, it's going to be the great gift to the Punekars, so they can think of making BRT free like they do it in other countries, because everything will be solar powered. So thanks a lot for attending. I appeal all the participants to become member and support this good cause. This is an NGO platform for technology seekers and technology givers, and Sunday lecture is part of the activity. We also have think tank and industry academia consortium. So do join us for various platforms to be created with your expertise. I conclude today's session thanking Mr. Dr. Sudhir Kumar for wonderful 2 sessions we had. It's a good one. And now henceforth, all the 6 sessions will be recorded, because we got our own Zoom supported by Mr. Ramesh Telang, and all the recordings will be available on our website. We had few recordings done last year, but not enough. And Dr. Telang, Mr. Telang wished that we should record all these lectures. It's a great pleasure for the TTA as well as the participants. So thank you very much. It's exactly 11 o'clock. We are able to complete the session in 1 hour. So thank you very much. Let's meet next Sunday for another exciting lecture on solar energy to be supported for BRT. Thank you all.
Okay. Thank you. Thank you all.
Thank you.